So in this video, we are starting our unit called Meteorology, and this will then lead us into our next unit of Climate. But first we'll talk about the current atmospheric conditions and how to describe the current conditions, what variables you use to describe them. We'll also be talking about high-low pressure systems, cold, warm, and stationary fronts to help us forecast or understand the current weather to forecast the future weather. So those are the things that we'll be working on. But first, in order to do that, we need to kind of go over some things. So the first thing that I want to talk about is the difference between weather and climate. Like I said, we are going to be talking about the weather, which is our current atmospheric conditions. We're going to talk about temperature, air pressure, wind, relative humidity, and dew point. But those current atmospheric conditions over a long period of time describe an area's climate. And usually you describe the climate as the area's average yearly temperature and the average yearly amount of precipitation that they get. We live in a temperate climate zone. So our first weather variable that I would like to talk about is temperature. Temperature is the measure of the average kinetic energy of the molecules in the material, or the air, the liquid, whatever it happens to be. And you can use a thermometer to help you take that measurement. And our units are Fahrenheit, Celsius, and Kelvins. And what I would like us to do now is to learn how to convert between these three units, and that leads to our reference table, page 13. So if you would, stop the video, grab your reference table, and then resume. So now you should be looking at page 13 of your reference table, and we are going to look at this chart right here, which is called the temperature chart. Here you can see the three units to measure the temperature, and this can be used to help us convert. We can be given a temperature in Celsius and asked what is it in Fahrenheit, or what would it be in kelvins, and we need to be able to use our reference table to help us. So let's say, for instance, the temperature is 30 degrees Celsius. So what we would do is we'd come down the Celsius, the center, and we'd find 30. And from here, we would then look over and we go straight across to see how many degrees Fahrenheit it is, and we'd go straight over to the right over here to see how many degrees Kelvin that is. Before I get a closer view on this, what I do want to go over with you is that when you do read this temperature chart, you want to remember that the center Celsius goes by 1 degrees at each little line, difference between one line to the next, and over here in Fahrenheit they go by 2s. So when you are converting over, you have to remember that. So I'll take a minute here to zoom in and check out this 30. So if it come down to 30, and I look straight over to the left, I will see that it's right here. And that is, normally you might want to say, oh, that's 30 or 83, but you want to remember they go by 2, so it's actually 82, 84, 86. So 30 degrees Celsius is 86 degrees Fahrenheit. What would it be in Kelvin? Well, the same thing. You come over here, go straight over, and if you do that, you'll see they go by 1s, and that goes up to the third line, so that's 303 kelvins. So that's how you would use this chart to convert. At the end of this video, I will be asking you to go into and do some more converting on a worksheet. So now that we've practiced converting temperatures between the three units, we also need to be able to draw isotherms, which are lines that connect points of equal temperature. And this goes back to our unit when we were talking about contour mapping, where we're connecting points of equal elevation. Here we can use the same techniques, the same rules to help us connect points of equal temperature. So this is the worksheet that I would like you to practice on. You should have one in front of you right now. However, before we get into this, I want to review with you how to draw isolines. So let's take a minute to review. So remember, when you're drawing isolines, you want to connect points of equal value, and you're also trying to draw a line to represent a value. And so here, let's say I would like to draw the line that represents 50 degrees Fahrenheit. So what I would do is I would start looking across. Remember, you should scan your data. There's the 50 here that I want to remember to get, but other than that I don't see any other 50s, but that doesn't mean I can't connect that and make an iso line to represent 50. So I kind of look over here on the edge of the map, I see 46, 42, so I know 50 is in there, and I can start to draw my line through the data. Even though I don't see a value of 50, I know where it would be because of the information around it. So come down around here the best I can, and I keep going over, and there we go. Remember, smooth curved lines, these lines never touch. They try to be somewhat parallel to each other. And so here, if I want to check myself, I can draw in the line, and you can see, check my work, see how I did. And what I would like you to do now is I'd like you to stop the video, and I would like you to go back to the worksheet that I just showed you and connect the points of equal value, the isotherms. Do that now, please. So after going through on your map, yours should look similar to this. So if you want to go ahead and check yourself to see how you did with drawing your lines, you can see that down here at the bottom, one of the things I wanted to see, if you actually connected these to each other, that would be fine. If you didn't, that's okay, to represent the line of 70. But double check. If you need to stop, rewind to see how you did, not a problem. One last thing about temperature that I wanted to talk about, especially now in wintertime, is wind chill. Wind chill is really determined by the wind speed. When there's no wind, the warm air around you stays by your body and makes you feel the temperature that you should be feeling. However, when the wind starts blowing, it blows that heat away from your body, so then your body will cool down and it will feel a lot colder to you than the actual air temperature. And here's a chart that helps you determine that. So the other day I woke up, it was -10 and the wind was blowing about 10 miles per hour, so it felt like it was -28 even though the air temperature read -10. So you have this chart in your notes as well, and you'll be asked a question on how to on using this chart, but that's how you would read it. And then down here it tells you the time, frostbite time, how long you would need to be out, in when frostbite would set in, and how long that would be after bare skin was exposed. The next atmospheric variable that we will be learning about is air pressure. And here at the top, it is the force of the atmosphere on you. And the surface here, we have all of the atmosphere above us. We feel a lot of pressure down here on us. We're used to it, we've accustomed to that, so we don't really notice it except for when there's pressure changes, such as here where you have rising air and sinking air can put more pressure on you and less pressure. How can you measure the pressure? Is by using a barometer. There's either the mercury barometer, which I have an image over here for you guys to look at, or an aneroid barometer, which you have over here. And the units to describe the atmospheric pressure is millibars, inches of mercury, and atmospheres. And one of the things you can also do using page 13 of your reference table is convert pressures. So what I would like us to do is I'm going to have you look again at your reference table, page 13, and I'm going to show you how to convert and things to watch out for when you are using that particular chart. So if you would, grab your page 13. So here on page 13, you're going to be using this part of your reference table that says pressure. Here you can see millibars and inches are 2 units for measuring air pressure, but you'll also see the third down here, 1 atmosphere, and what it will be equal to when you are using this chart in millibars and inches of mercury. So one of the things that we want to make sure we do when we look at this is on the millibar side, they go by 1 millibars. So this is 1037, 1038, 1039, 140. So one of the things to watch out for over here, however, it's a little different. It goes by 0.01s. So what does that mean? It means when you look at this one, this is 30.60. The next one up is 30.61, 30.62, and so on all the way up. So when you are converting back and forth, make sure you stop and be aware of those kinds of changes. And what I would like you to do is at the end of the video, like I said before, you're going to practice this converting. But for now, we're going to continue on with our atmospheric pressure and drawing figures. Things you want to start to remember and think about is that the atmosphere's pressure changes all the time. And there's the reasons why it might change. There might be changes within the air density that will, and then in turn, change the atmospheric pressure on us. It might increase or decrease. The changes in the air temperature can cause air pressure changes as well. And also, as we move up in our elevation, meaning up in altitude in our atmosphere, that will also change the pressure that the atmosphere is on us. And so those things working together can change the pressure by seconds, by hours, by days. And we will talk about areas of high and low pressure later on in this unit. But the next thing we also need to be able to do is on a weather map, draw ISO lines, again, that connect points of equal pressure. So here we call them isobars. And when we draw isobars, we can actually, you're going to be making circles because they're going to help you zero in on the areas where there's the highest pressure and lowest pressure. So if you would, take the worksheet back out that we used to help us draw the isotherms, and we're going to use that to help us with isobars. So if you could do that now. So here's the worksheet that I would like you to work on now. I would like you to stop the video and connect points of equal air pressure. I would like you to start with the 124s and connect those. You'll see that they will make a circle. And then do the 120s, and then you're going to go through the directions and go all the way to 1008, connect points of equal value. Remember, they're going to be circles, they're not going to be lines that are moving across the United States like you saw with the isotherms. And when you are finished, what I would like you to do is in the center of the two circles, I'd like you to determine which one you believe is the high pressure and which one would be the low pressure system. Where would I label the L and where would I label the H? And down here is the directions for that. So please stop the video and try that now. So here is the answer to your ISO lines. You can see that all the values connected, and then you can also see where the H is labeled in the center of here because that has the highest pressure value inside within the circle, and here is the lowest pressure value, and that's why I put the L in there. And usually on weather maps they're labeled with blue for highs and reds for lows. You didn't have to do that, but that's the reason why. We also can interpret these ISO lines here with isobars because we're going to learn that wind is a result in differences in air pressure. And we can look at the closeness and the spacings of these lines to determine how the wind speed would be moving through there. Would it be moving fast or slow? So here you can see the weather map. Here the ISO lines were drawn, and at the very center is a low. And over here you can see how closely spaced these lines are. So that would mean the wind velocity is very fast here compared to where they are over here where the lines are spaced out. Just like we learned with contour maps that when the lines were closer together, we had a steeper slope. Here it's faster wind velocity. And here's another type of picture to help you with that. So here's our last variable that we'd like to talk about today, which is wind. And wind is caused by differences in air pressure. And wind always moves from areas of high pressure to low. And the instruments that we use, there are two of them, they have two different jobs. A wind vane, which you see here, and at the very bottom part of this particular instrument, is how we measure the wind direction. Which direction is the wind coming from? And that's one of the things that we have here. Wind's always described as where it's coming from, not where it's going to. And an anemometer, which is the other one here, is the cups at the top here that spin around to help determine the wind speed. And that's one of the things that you need to remember. One of our Regents questions are always the weather variables and what instruments used to measure with them. And the most often asked is the anemometer because of the wind speed and the vane because of the wind direction. Two different instruments doing two different things. Here's your units. And here's some reasons why the winds may change and move, differences in pressure, the friction between the surface of the earth, because sometimes if there's a lot of friction it will slow it down or maybe speed it up. And the Coriolis effect also affects the wind direction, which we'll be talking about later. And this concludes our video, so what I'd like you to do is stop and move into Schoology and get your conversion worksheet and try practicing using page 13 of your reference table to convert temperatures and pressures, and then you should have already practiced your isobars and isotherm drawing.